Welcome, everybody. My name is Brian Smith. I'm with Tennant Company here and want to welcome you all to the first in a series of webinars in our Educational Facilities Management webinar series. Today's webinar will be on smart staffing and how to make workloading easy. We know that the world is asking our industry to consistently do more with less, and we'll be talking a little bit today about how to deploy your hardworking staff to make sure that you're getting the most out of them and able to achieve the highest levels of performance within your organization. Tennant is proud and fortunate to welcome Dave Frank, who's going to be giving our session today. Dave is the president of the American Institute for Cleaning Sciences, has been working in our industry for over 37 years, and is a leading authority in industry best practices, and working with distributors and manufacturers and service providers around the country. He's been very active with member and speaker for organizations like ISSA, APA, and the U.S. Green Building Council. He also is the architect and administrator for the SIMS program for ISSA, which is a certification program for all levels of folks in our cleaning industry. So I want to welcome Dave, and we'll go ahead and get started.
Thank you, Brian. Good morning to some of you, and good afternoon to others on the East Coast. Workloading is one of the more sophisticated subject matters that we're going to be doing over this webinar series. There will be 5 webinars over the next 5 weeks. The financial component of our business is embedded within workloading. There's also a management component that goes along with it, and a lot of people find the whole subject matter to be complex. And what we want to do in this session is we want to demystify the platform as to how we perform workloading, how we gather the data, some of the tools, and then we'll talk about the production rates, and then we'll give some modeling that will show ways to drive cost out of the system using the information. But the information is all about garbage in, garbage out. So with the data that's needed to effectively do workloading is the most important piece. So we have to collect the building data. We have to understand what the scheduling is. We have to understand our mechanization. We have to understand the actual production rates, not the production rates that come out of a book, but the production rates that are in your buildings with your people and your machines or your cleaning structure. So there is no right or wrong on this subject. It's really a matter of understanding the framework as to how we get there. So one is looking at the actual budgets, because labor is the most dominant piece of what we do. The production rates that the industries publish have been repurposed, and some of those production rates may not be the most practical rate. Now, for many of you, you may be a contract cleaner, you may be a K-12 school or higher education or healthcare. Production rates change by the types of buildings that we're in and then the conditions of those buildings, whether it be the age or the occupants. And so then once we have all the data, we have the information, we want to be able to identify that to come up with the right staffing level. Now, this is a subject matter that we take very seriously because this is about people's jobs. So if we don't have the right data or someone miscalculates the square footage of a building or the cleanable square footage of a building, it could throw all of the numbers off. So it's always best to make sure that you have the baseline information and that you're able to verify that information with a couple of different sets of eyes. There are a variety of different benchmark statistics that are out there. Benchmarking is very difficult to do building by building because one university or one high school may have different conditions that change the benchmark or the production rate of that specific building. Normally, we don't really workload buildings on a longhand basis unless we're on the job site. It's very difficult to do it from great distance. We can certainly get some shorthand numbers, but if you want to do it correctly, walking around a building certainly will tell you why the cost of cleaning one building may be higher than another. Then we'll look at the actual methodologies, and we'll give you examples as to how we can put that all together. The first part of this is to understand the financial influence chart, because a lot of people want to oversimplify the numbers, and there is no such thing as a piece of cake when it comes to the number. And people have to understand that the department, the bean counters and the upper managers in the departments, it's not that they're picking on us, it's just that we happen to be the biggest budget, and I'll show that in the next slide. But at the bottom of the influence chart are manufacturers and distributors. It's not a bad thing, it's just the way that the numbers, as it relates to the budget, is mostly dominated by labor. So above that tier is the building service contractors and the in-house service providers. That's where the direct labor sits. Now, a lot of people say the number is 90-10 or they give a number that's high. Direct labor can be 45, 50, 55%. Then you're going to have benefits, potentially union dues. You're going to have overhead, supervision. There's a lot of things that make up the actual direct labor side of what we do. Then you've got the building owners and the property managers in the private sector, and then in the public sector you have school boards, the executive levels within universities and hospitals and other types of verticals. They're managing what we classify as a maintenance and operations budget, of which cleaning is a piece of it, but it's the most significant piece of it. And then above all, the folks within the stakeholders within the cleaning industry is the consumer. There's a couple of things that we know about cleaning budgets is that cleaning is a double-edged sword. It's both perceived as a cost and it's also perceived as a profit center. And the reason that we say that is dirty buildings don't sell well. Everybody can see them, and it's very difficult to generate revenue in a commercial or a public sector building when we look at the cleanliness piece. And when we say public sector buildings generate revenue, they generate revenue by keeping customers happy and making sure that especially in schools and universities, that parents and grandparents and people in the community see it as a safe place for their children. They do have options. They can certainly look at religious schools, or they can look at private schools or charter schools, and we're seeing a lot of movement in the public sector for K through 12 schools looking to standards such as SIMS and APA and other ways in which they can improve their operation, increase their cleanliness, and keep their customers happy and people in their community satisfied with the outcome. These two graphs are important graphs because they really show why they're picking on us as an industry. And we've been in the business long enough to be able to gather some of these graphs and charts because we were always wondering why the grounds guys got, new John Deere mowers and why the cleaning department wasn't getting the types of equipment, whether it's scrubbers, restroom cleaning machines, vacuum cleaners, to be more effective and efficient. And so I asked a friend of mine who worked in a university if he could get a hold of the total M&O budget. And so on the far left, and this number can actually be as high as 40%. And the analogy that I make is in some parts of the country, they're only mowing the lawn 34 weeks out of the year, but they're cleaning the building 365 days a year, depending on the types of buildings and how frequently they're open. So the cleaning budget itself is the size of the next 5 largest departments combined. They don't buy toilet tissue, and they don't buy hand soap and maintenance equipment as much in relationship to the hammers and nails that they're using in the other departments. And so what we see is we see how big the department is, which is why since 2008, when the recession occurred, you saw a lot of the white-collar administrators starting to ask questions about cleaning operations and the cost structure, which is why workloading has become a much more popular subject. On the far right graph, you see the direct labor, the benefits piece, and the cleaning products piece. The performance of cleaning products is critical, but we mostly relate that to, again, the outcome and the production. Workloading is not about trying to get janitors to work faster, and we're not looking to kill cleaning workers within the operation. What we're looking at is can we mechanize the task, make their jobs easier, potentially reduce work-related injuries, and can we drive cost out of the system? And we have to know what the cost is before we can drive the cost out of the system, and that's why workloading information is critical. This is a slide that's requested in a lot of our educational courses because it identifies, like the last graphs identified the supplies and the labor. What's also needs to be identified, and we're in some meetings that some people might classify as not being very much fun, but it's looking at the human resources the management of the human resources. And so insurance costs, the risk, the safety, the workers' comp claims, days away from work, potential inefficiencies, our workers being trained, there's a cost associated with doing that. Do we have a sustainability policy? Do we have overlapping products? Do we have sustainable products? Sometimes we see harsh products in an elementary school with 6-year-olds, and they're really not necessary. So these costs, supply chain inefficiencies, these are the costs that represent the total department, or what might be seen as the hidden costs. And so everything is connected when it comes to the cost of a cleaning operation, and these top 12 are the primary cost structures. Sometimes workers' comp claims can be high, and that can be remediated with the right types of training or potentially mechanizing a function that's being performed by hand, i.e. mopping a floor with a mop and bucket versus using a small or a medium or large or even a rider scrubber. Okay, user data. This is a graph that came from Gene Woodward at the University of Washington, and we refer to it as a lobster claw. And the reason why is on the far right, you see what we would classify as the perfect storm. This is an increase in the square footage of the buildings on the campus and an actual reduction of FTEs on a simultaneous level. You also see the gross square footage increased, and you also saw the FTEs increase pretty dramatically, and it was right around that recession period where they went from 327 FTEs to 287 FTEs. Now, that is a very dramatic difference in the number of employees that are cleaning the building. And he changed his entire cleaning operation. He gathered a bunch of data. One of the sessions that we're going to be doing in this webinar series is a seminar on big data, and Gene is going to be displaying some of those things. So if you have the time to attend one of the other sessions, he'll be elaborating on what he did after he was able to gather this. Now, this graph is not unusual, and the reason that this occurs is because of the lack of data. When someone says, well, look, we're going to build a $250,000 square foot commercial building, and we're not going to give you any more FTEs to clean it, that's impossible. What's happening is that there has to be a number to say, okay, we're building a new building, we workloaded the building, here's how many FTEs we're going to need to clean, let's say if I'm in a school at an APA level 2 or an APA level 3, if there's some reasonable number in the middle of that score. So when we're looking at it, the data helps us not only make decisions to justify the budget, but we can't be operating in a black hole where we come back and tell an administrator, well, we'll just do the best we can. Then all of a sudden, cleanliness declines. The health impact can be severe depending on how dirty that facility gets. It can affect indoor air quality. It can have an impact on potential slip and falls. It can have an impact on the assets or the life cycle of an actual building. So remember that all the subjects tie together, and the center of the plate is workloading. Many people ask, many of the people that work in our industry are afraid of the bosses. I don't want you to be afraid of the bosses. The bosses are asking a good question. And the number 2 bullet is the question, is how many people do I need to clean this building? And the question is based on what are the tasks, what is the frequency, what type of surfaces do we have, what is the production rate. We know from working with architects that you can build a building to have a lower cost of cleaning. We know that certain surfaces have a lower cost of cleaning than other types of surfaces. So when we look at it, all buildings are different, all surfaces are different, the expectations are different, but it is not unreasonable for a boss to ask the question, how many people do we need to clean this building? And we realize that cleaning is not a race, but when we have industry standards like SIMS, we have industry textbooks like the APA textbook, we're able to coordinate all this information to be able to measure the quality, the production rate, the actual cost. Now, the outcome that people seek is, and people ask me all the time, I said, look, what they want is they want a green, clean, safe building at the lowest possible cost. Now, that's really easy to say, but the actual coordination of the policies, the procedures, the data, the numbers, the supervision, the corrective action policies, those all come together to equal that positive outcome. and it can be accomplished, but it has to be accomplished with information. Okay, let's get into the heart of the matter, how we calculate the cleaning costs. There are a lot of different ways to come up with numbers, and there's different types of software. There's software in our industry from $130 all the way up to $20,000, $30,000. There are also some folks on this call that may have built their own spreadsheets to determine their actual labor cost, and that's something that's not that difficult to do. So shorthand workloading is a matter of saying, okay, the building is 100,000 square feet. My production rates are 5,000 square feet an hour. I need 20 hours of labor per night to clean that building. That's a very quick way to do shorthand. There's also some very, what we would call entry-level software, and I'm going to use it to show you the examples, which will workload buildings up to 75,000 square feet with some very, very elementary tasks. You can adjust production rates. You could workload a floor job. You could workload a carpet cleaning job. You could also evaluate the cost of mopping a floor by hand versus using a scrubber. You can put in some benefits, but the program for its price has a lot of utility. The most advanced level of workloading software is what we call visual-based workloading software. These are for multi-million square foot facilities, which can have multiple shifts. You can import the CAD data from blueprints. You can color code those, as you see on the map on the right. And you can coordinate shifts, you can make changes, you can schedule project-type work, you can put in floaters. There's all types of things that we actually had one of our clients ask us if they could put grounds or painting of the building in that software, and you actually can do other types of tasks such as that. You can also put work tickets, but these software programs, not just the cost of the program, but you have to determine if your organization has a FTE or an individual that has knowledge of the industry and also is computer savvy. And so the software programs in that category can run anywhere from $5,000 to $20,000. Okay, data-driven decision making. If you're in the business and you're, let's say, a contract cleaner, it's very dangerous if you don't know how to do workloading. And the shorthand workloading is good for smaller buildings, but if you get into industrial sites, multi-building campuses like a university, with the complexities of schools, K-12 schools, where buildings are being used as community centers, and you have non-cleaning tasks that actually factor into the total cost or the FTEs, the information that you get is critical to what you do. Shorthand workloading gives us a snapshot, but doing deep dives and then doing a forensics on the actual tasks and frequencies and production rates certainly can give you even more detailed information. Now, we had a K-12 school that went through a pretty severe budget cut. And in our industry, little numbers equal big numbers. So I said, well, how many FTEs do you need to cut? And they said 50. Now, 50 FTEs is equal to about $2 million budget cut on a $30 million budget total. So I took the number and said, okay, it's 350 hours of cleaning per day that's no longer occurring. Then I took the 350 and I took it as around 260 days. Most schools clean 195 days a year, but because they do all the project work in the summertime, I booked it out at 260. Then I asked the question, how are you going to extract 91,000 hours of cleaning out of the school? I said, what's the plan? They said, we have no plan. We have no methodology in order to do that. And so, and that's because they didn't have any workloading. They didn't know what buildings were doing what they were performing. And they certainly had a lot of options, but when push comes to shove and you either are looking for an increase in the FTEs to accomplish higher levels of cleanliness, or you're looking to flatline it and leave it alone and increase your cleanliness, or if you go through a budget cut, you have to have a roadmap to have an intelligent conversation about numbers as to what you do, what are the standards, what are the appearance levels. And so the industry is sophisticated now. We have standards and we have information so that you're not alone. And then if you need some specific help, the folks at Tennant can help you. We can also work with them and work with you to help you if you're looking for more information. These are the 5 cornerstones of the workloading process. One is we have to understand our inventory space, and that's actually either grabbing CAD data to determine what our square footage is, what types of floor surfaces we have, because the floor surfaces will actually change the total cost of cleaning. As an example, 100,000 square foot of vinyl tile versus 100,000 square foot of carpeting, the annual cost of labor of cleaning those two surfaces can be the difference of almost $25,000 to $30,000 a year. Carpet is less expensive to clean than vinyl tile, and it's because of the stripping cycles, the top scrubbing cycles, the burnishing cycles can make that up. We also see people putting in polished concrete, which can have an impact, and you see that in a lot of new or green buildings where they're looking to change the appearance or to put in a different type of substrate. The scope of work is critical. We're in a lot of job sites where people don't have a scope of work. What are the tasks that are supposed to be performed on a daily, weekly, monthly, quarterly, annual basis? What are the frequencies, and what should those frequencies be based on? What are the actual production rates? How long does it take to clean a classroom? If I'm in a hallway, the scrubber may say on the brochure that it's 20,000 square feet an hour, but with all the setup time and the obstacle time, that scrubber may only get 9,000 square feet per hour in your specific building. And so it's important to understand the production rates, or potentially you could do your own time study of how long it takes to clean a classroom. Then we determine the labor hours and what is the annual cost. And so changing a production rate, mechanization, or looking at a frequency will change the total labor hours. And then there's job costs. This is everything from background checks to uniforms to administrators within the department, having admin, supervision. These are all additional costs that have to be considered that are part of the total. So let's talk about production rates. Production rates are the time needed to complete a specific task. A lot of people have to consider setup time, breakdown time, and potentially travel time. And so some sophisticated job sites, I've been on some industrial job sites where, although we might consider it to be a 7-hour work shift, they had an extreme amount of travel time where custodians were loaded into a van and had to be moved around. Some job sites, it's a building, and the custodians are in the building, and there's some obstacles, but they're not as extreme as having to transport people from one job site to another. So every building is different, every job site is different, and you can calculate those costs, or you can consider those costs in your workloading process. So here's how production rates are calculated within our industry. You can certainly walk a facility and say we have 300 trash cans. And then it's going to depend on the size of the trash can, the location, and the complexity of that trash can. And people say, well, how complex can they be? I said, some of them can be complex, and getting trash in and out of them just doesn't take 30 seconds or a minute. You can also take that same function, and that's what we would call a unit or per item production rate. You can also take that same number and say, well, performing trash in this building is at 15,000 square feet an hour. So depending on the type of building that it is, you might use one or you might use the other. If you're in a large industrial manufacturing facility, you would not use the 15,000 square feet per hour. The production rate will make the number fly off the handle. So what we would do is we would count the number of large barrels. They're probably using a tilt truck in those areas, and it might be 2 minutes or 4 minutes per trash can, but depending on the travel time. Then in the third category, you see minutes per fixture. When it comes to restroom cleaning is, well, let's just say it's 50% of the complaints. It's 5% of the square footage, and it's about 20 to 25% of the total labor. It's the most important room of the house. And when I look at it, we can certainly come back and say it's 2 minutes per fixture in a Class A office building. It's 3 minutes per fixture in a K-12 school or a university. In an industrial facility that's really soiled, it might be 4 minutes per fixture. A fixture is classified as a toilet, sink, and urinal. And then the Bradley 360s or the Bradley half-moon sinks would be a separate fixture. And then shower heads, sometimes depending on how mechanized you are for cleaning showers and locker rooms, that might also be at 2 to 3 minutes per shower head. Then the holy grail, and this is a number that a lot of people are looking at, is what is our production rate per worker per hour? Is how much can they clean, how many square feet can they clean in a 60-minute window? And of course, that's based again on mechanization, workflow, the production of the machine, and the experience or the training that that worker may have. So these are a variety of different production rates that can be put into the software program. I certainly have the ability to take a restroom, and some people are using all-surface machines, which are basically pressure washers with vacuums on them, to clean restrooms. And the mechanization just doesn't deliver productivity. It delivers higher QA scores. And so the quality assurance scores are higher and the complaints are less when we mechanize that task in universities and K through 12 schools and also in some industrial job sites. And then people say, well, how much more productive is it? I said, well, I'd rather have a better QA score and lower my complaints by 40% than to worry about the production. Because the setup time and the breakdown time may not equate into a more productive task, but it will equate into a more satisfied customer because that's the most important room in the house, and it's the one that fetches the most amount of phone calls and complaints. There are a variety of sources for production rates, and I can tell you because we've seen them in reality, many of the production rates that are published today are off by 20, 30, 40, 50%. That is a very dangerous number for a production rate to be off. And many of these production rates have been repurposed. Sometimes we'll ask a custodian, how long does it take you to clean a classroom? They might respond with 10 minutes, 12 minutes, 18 minutes, depending on the tasks that are supposed to be performed that day or the actual soil level. So be careful when looking at production rates because sometimes the rate is over, sometimes the rate is under. It's not a bad idea for some of the managers who are on this call. If you came up through the ranks, you have some idea on what the production rates are that you were doing when you were working on the front lines. These are the variables that come into affecting production rates, and that's why a university on the East Coast that has a number of snow days a year, different types of traffic, a lot of rain, with a building that's 200 years old is probably going to have a different set of production rates than a building in Arizona that doesn't have extreme weather conditions. And so when people ask, well, why is this university or this school got this production rate and why do they have this, we usually pop up this slide because these have an impact on the total cost of cleaning. And so one building could be $30,000 less a year to clean than another building with the identical square footage. But the surfaces are different. The age of the building may be different. The occupants of the building may be different. So an elementary school, in some cases, is not nearly as soiled as a high school, where I have things going on in a high school that may not be going on within an elementary school. And so there are certain things that we know, but you've got to make sure that when people ask a question about benchmark data, that you have an idea of what some of these variables are that can affect the cost of one building versus the cost of another. Okay, space inventory. We were working with a client, and naturally, everybody starts pulling out blueprints. And so the blueprints tell us a bunch of information about the space inventory. And so these can be color-coded like this simple map is here, where you're figuring out what rooms have what types of surfaces in them. So if it's ceramic tile, marble, carpet, VCT tile, if it's asbestos tile, it's going to require a different type of treatment, and there's EPA regulations around that. And so what is the frequency? What do I want it to look like? And what is the square footage of the area? Then from here, we can plug in the square footage. We can assign tasks and production rates, which will calculate the number of hours per year and the FTEs per year to calculate the total cost. So this image on the right is an image of a hospital. And this is what we call a CAD drawing that gets exported and imported back into workloading software. Requires a little bit of technology, and you've got to have some people that are savvy with the software, but this is one methodology that you can do. You can certainly pull fire exit maps and be as simple as grabbing a pack of highlighters and classifying the area. So it doesn't need to be complex, but there's different degrees of sophistication. So whether it's blueprints, fire exit maps, CAD data, or if you have an old building where you don't have any of that, then you can certainly shoot that building with a laser measuring device, and we use all of these tools within our business. The image on the far left is a laser measuring device. You can purchase those at Home Depot, Lowe's, for a little less than $100. There are also sophisticated ones. The one in that gentleman's hand, we own that one. That's about a $400 laser measuring device. There's also walk wheels that you can attach to your computer where you can actually measure along blueprints, and it will import that data into an Excel spreadsheet. And then on the far right is these inexpensive walk wheels. And sometimes in large buildings where we might have a 200-foot hallway, the laser measuring device may not make it 200 feet. So what we'll do is we'll just walk it with a walk wheel, and these are anywhere from $25 up to $150, $175 for ones that have electronic panels in them, and they're adequate. As long as I can get an idea, I don't need to be that precise. I just need to get an idea of how large that hallway is, how wide that hallway is, so I can determine what form of mechanization, whether it's a small micro rider or whether it's just a 20-inch single disc scrubber, what is the way in which I'm going to mechanize that task. From there, you'll see sheets that look like this. And so office area, description, VCT tile, carpet, length, width, square footage. And then there's always special notes. So over on the right, we would say that it would be highly occupied, or it's a high traffic area, or you see the high density note. You also see the note here that the president's office has cut-end pile, where the rest of the building may be cut-end loop pile. And so in this building, we might use a large walk-behind battery sweeper in large open areas for the carpeting. We might use a backpack vacuum in the classrooms where it's where you have a lot of congestion and a lot of obstacles, and the backpacks move pretty well through those areas. And then in the president's office or the administrator's office, we're going to use an upright vacuum because they want to see the V-shaped patterns in the plush pile, because that's a visual identification that something's been cleaned. So it's not one size fits all. It may be multiple ways to come up with what we're going to use once we have the data in the way of equipment. One of the more important things in facility management is having a scope of work. Now, the scope of work tells us what the tasks are, and it also can tell us what type of tool to use. Whether we're using a microfiber, whether we're using a scrubber, a restroom cleaning machine, a backpack vacuum, an upright vacuum, you can be very definitive and specific with the actual description. You also see on the far right that we're giving it actual frequencies. And so once you have this, this is a list the custodians should have so that people aren't looking at you saying, well, that's not my job. Once you have the scope of work, you say, well, this is the job description, and here are the tasks, and this is how frequently that we should be performing them. So if we're going to clean whiteboards once a week, or are we cleaning whiteboards every day, but it shouldn't be as needed, because as needed is a very dangerous term that leaves us in a black box, letting a custodian determine their definition of what as needed is. And so this is one of the more critical components of workloading, but it's also one of the more critical components of managing a cleaning operation. Within the software, you're going to see frequencies that look like this. And the frequencies are, well, how often do we strip? Some people say we do it once a year. There are some people that are trying to extend their stripping cycles to every 24 months, whereby they would top scrub and recoat on that off year versus taking the floor all the way down. And that works very well at extending life cycles and potentially reducing summertime hours that can be reallocated for other types of cleaning activity. We're not using workloading on a regular basis just to reduce cost or headcount. What we're looking to do is use it to justify budgets, answer tough questions, and then be able to reallocate the labor to increase areas. There's always something to clean, and there's always something to do, and sometimes using efficiencies to reallocate labor to increase appearance levels and standards is also important. But within the software programs or in a spreadsheet, you will see these types of frequencies. If you decrease the frequency, it will decrease the cost dramatically. If you increase it, it can increase the cost. Many times when people ask me the question, and they'll say, well, can we clean classrooms every other day? I said, well, you can do what you want, but that's a high-risk area because the classroom is like 600 square feet, and I'm changing it 6 or 7 times a day. So you're bringing in 180 to 210 human beings, children, in and out of that classroom. To me, classrooms shouldn't be skip cleaned. I can certainly skip clean other areas if I have budget cuts, but I have to identify what's a high risk, what's a low risk, what's negotiable, and what's not before I make any decision that would look like that. When we talk about significant risks, when we say risk assessment, if you're going through budget cuts, the risk assessment, these are 5 levels of risk that come out of some of the European standards. We apply them within education and other types of verticals because our industry is just not dumping the trash. It's addressing highly touched objects, high-risk areas, and before we make any reductions in frequencies, once we know our scopes and our costs, we have to make sure that we don't reduce what we would classify as high to very high-risk areas. Measure the space, develop the scope, apply a production rate, determine the labor hours, and then calculate additional job costs related to the operation. Okay. The additional job costs can be labor, it can be benefits, union benefits, wages, chemicals and supplies will usually be in that 5 to 10% range. Paper and consumables. Capital equipment is a capital expenditure. When you get into doing a large automatic scrubber, Tennant has a return on investment software program where you can look at what would be the 3-year period for depreciation, because that's what the accountants want to see, and then what is the return on the capital investment that you're making within the operation. There's also recruiting, uniforms, background checks, any subcontractor. There's ancillary costs. There's additional slides that we only had so much time here. This is like a 7-hour course that we're teaching here in an hour, so we're doing a lot of compression. Okay, we're on the 5-yard line here, so let's go ahead and give you a few examples, then we'll open it up for questions. The best way to look at the actual cost is one, reduce the frequency of the task. In some cases, some tasks are being overperformed and then other tasks are being underperformed. And so what we do is we look at it and people will say, well, how often should that occur? And we'll say, well, how often is it occurring now? Some people may say, well, look, we do the whiteboards daily. Well, the whiteboards may be better served to let the teachers do them and then to just do them once a week with a microfiber trowel or a short-handled flat mop. We can eliminate the task completely. If there's a certain task that's occurring, sometimes that task is occurring because I'm using the wrong product or I'm using the wrong chemical. And what it's doing is it's not cleaning dirt, it's actually regenerating it, and we can eliminate that task by evaluating the process, the practice, and the outcome of that specific task. There's no question in my mind, and we've seen it in the field, that a small auto scrubber, even in a small high school that's got 30,000 square feet, will perform better and faster and give me a cleaner surface than will a mop bucket and a wringer. And some of these scrubbers are, 5, 6 gallons. Some of them may be a small 20-inch machine. But whatever it is, mechanization always cleans better than performing a job by hand. Mechanize the task, improve the process, and then our industry spends millions of dollars every year innovating product, trying to produce a better mousetrap. Just make sure that the mousetrap is effective on your job site and that you have buy-in from your people because they're the ones that are going to be using it. We see a lot of equipment in janitors' closets that was purchased with good intentions, but the custodian won't use it for one reason or another, and if you ask them, they'll usually tell you why. Okay, workloading example. Box number 1, 2, 3, and 4 are color-coded. In the purple zone, we're putting in wages, and I know those wages are low, but this is just for example purposes. Then you type in the benefits, or you hit the slider, and that gives us benefits. It could be as high as 30, 40%. We did not touch the FTE hours. We left that at a full 2,080 per year. That can certainly be adjusted for vacation time and sick time. But what I want you to focus on is 2, 3, and 4. So here we are. We have 50,000 square feet of carpet. We are going to use a box extractor and a wand at 500 square feet per hour. That gives us a total cost of $4,000, roughly. Top scrub and recoat, 25,000 square feet would be a small elementary school. 3 times a year, 2,700. Some people only do it once a year, or they don't do top scrub and recoat at all. 25,000 square feet, 4 coats of finish. 1 time a year, $1,500 in total cost of labor. That does not include finish, stripper, mops, and all the ancillary items. So our total wet work is $8,000. Then in the green area, you're seeing restrooms, 3 minutes per fixture, $12,000. Detail vacuuming, backpack vacuum, $4,000. Traffic vacuuming with an upright vacuum, $35,000 is the biggest number on the screen. Dusting, trash, $12,000. Dust mopping, $3,000. Damp mopping by hand, $12,000. I'm going to mechanize that task with a scrubber. Burnishing, $4,000, 3 times per year. I'm going to see if we can get a higher quality finish and reduce that cost. The cost of cleaning this building is about $96,000 with 4.69 FTEs. Now I'm going to take those 3 things I talked about, frequencies, mechanization, analyzing the cost structure, and we're going to drive cost out of this building. Now remember that when you're looking at the total cost, and this is the slide before this one, vacuuming is 45%, trash is 16%, and restrooms are 16%. You will normally see that in most buildings that 75% of the total cost of cleaning is 3, no more than 4 tasks. And then then you see floors, vacuuming, dust mopping, dusting, and burnishing are the smaller piece of the pie. So if we could mechanize and organize the 75, 77%, that's where we can increase quality and drive cost out of the system. So the orange arrows is where I made some improvements. And so if you were to take the 50,000 square feet of tile and you were to look at the of carpeting, what you would do is we're going to take that away from using a box extractor, and we're going to put in a encapsulation or a soil suspension unit. These are small machines. Tennant has a couple of them. They also have large riders that do this, and we're going to move that production rate from 500 square feet an hour to 3,000 square feet an hour, and we're taking almost $4,000 in cost out of that task. We're going to put in a higher quality floor finish, something that may be harder versus softer, maybe an 18% solids versus a 25% solids. And we're going to decrease the frequency of scrubbing and recoating and save about $1,000 on that task. We're leaving the strip and recoat cycle alone. We took about $4,000 out of the project work. If you go down into the green area, you'll see auto scrubber. Instead of mopping the floor by hand at 5,000 square feet an hour, we put in a 20-inch single-disc auto scrubber at about 10,000 square feet an hour and reduced the annual cost of cleaning the floors by $6,000 per year. Because we have a higher quality finish, instead of burnishing that floor 3 times a week, we're going to burnish that floor 1 time a week, and then we're going to see how it looks. So now we took the cost of cleaning this building to $82,000 with our understanding of frequency, production rates, and mechanization. It wasn't overly complex, but you have to know your gear in order to do this, and you have to understand what the best practice is, the surfaces, and all those details. Now, the biggest number on this screen is $35,000, and that's for an upright vacuum at about 4,000 square feet per hour. Now, I realize, because I'm comfortably in my 50s, we won't get into details on that number. But I do realize that some custodians don't want to wear backpack vacuums. There are some custodians that love backpack vacuums, but the production rate of a backpack vacuum could be anywhere from 2 to 3 times higher than an upright. So on this specific building, I am going to put a backpack vacuum in here. and I am going to take an additional $17,000 out of the cost of cleaning. So you see the number went from $35,000 to $17,000. And again, I get a lot of pushback, and I understand, the I don't want to wear my vacuum story. But I also know in cleaning some types of buildings, because I came up through the ranks, is that sometimes the obstacles that we have to clean around actually can cause more fatigue than wearing the vacuum itself. And so in this case, we now bring the cost of cleaning down to $64,000. So we went from 4.5 FTEs to roughly 3.25 FTEs, 3.17. And so we'll put this in graph form. And the difference in these three buildings is significant. And so the people on this call, this subject matter is one of the most important subject matters because it has tremendous financial impacts if you understand, what is going on in a building versus what's not going on. And then you can certainly do some value engineering and change floor surfaces to lower cost. You can do the mechanization, the evaluation of the frequency, the looking at the production rate. But I'm a big proponent of mechanization, and not just in commercial buildings. I'm a big proponent of mechanization at home. When I'm cleaning something, I want, pressure washers at 3,000 PSI. I want, auto scrubbers to do specific jobs. What I look at is can I get in, get out, do the job as quickly as possible, and then I want to focus on the outcome. The outcome is a clean building. If your buildings aren't clean, everybody sees the lack of the outcome. And so whether you want to improve appearance, whether you want to drive cost out of the system, whether you want to tell your boss that you're understaffed, workloading is the subject matter that gets you there. And it does take time. It gets a lot of people to be asking questions. And for those of you in K-12 schools and universities that are on the call, and I wanted to cover this, I just didn't have a lot of time because we're at the end here, is that your non-cleaning tasks can represent anywhere from 15 to 25% of the total cost of labor. And we know that because we actually gathered lists of those non-cleaning tasks, looked at frequencies, times. We actually put them into workloading software. And so one of the things that I think is important, and a lot of people think that, the lack of documentation is good because I'm hiding something, I can tell you that it's best to be transparent, and it's best to be able to take all of your information, including your community service and your non-cleaning activities like mending fences and shoveling snow and inspecting fire extinguishers. Those types of tasks take time, and we classify those as non-custodial tasks, and it's not a bad idea as part of the workloading to include those in. Because if you take a $30 million budget and you say 20% of our cleaning is non-cleaning tasks, that's $6 million in labor. That's a pretty significant number for things that have nothing to do with cleaning. And that's why I would go after everything and all to be able to get the right type of snapshot.